started, don't I? Okay. We're up on YouTube, and actually, until I think your Twitch name is Bluey. If you're here, let me know, and I'll get straight to your question. Hey, Eberman, you have to fight out for first the Spectry. Oh, you're here? Okay, cool. Let me open up your question now, then. Okay, so it looks like there's two here. Let's look at the bottom one, I guess. That should be 5 squared. Oh, it's an option. There should be 10, but you don't know why. Oh, okay, so this is using our trig functions. Let me make this image bigger. So if you're saying that you thought your idea was that the answer is 5 squared, that's not a bad guess. I assume you're trying to use the Pythagorean theorem here. But for this, that's actually not the strategy that we want here. Since you can use the Pythagorean theorem if you have two sides and you want to get the third side. But here we have a side and an angle, so we need to use a different strategy. I guess there's technically two different ways that you could do this, but the way that I would kind of recommend to go about this is to use trig. Hey Jed, yeah. It's just this one. It's not anything like that fancy though, where you get too excited. So this one we have an angle. It's adjacent side, and we want the hypotenuse. So here we need to remember that cosine is adjacent over hypotenuse, and we're going to want to use a cosine here, basically. Should I? SOHCAHTOA, yeah, exactly. You may learn it as SOHCAHTOA, as Jed said. Let me actually draw this on the board because I want to make sure that you know like how to set up this equation and solve for x. Okay. $60-degree angle, 5, 90-degree, and x. Okay. So we know that cosine of that angle 60 is adjacent over hypotenuse. In this case, adjacent is 5, and hypotenuse is x. And we want to solve this equation here for x. So now it's just kind of normal algebra, I guess. So I multiply each side by x, and we get x times cosine of 60 equals 5. Now divide each side by cosine of 60. X is 5 over cosine 60. Technically that is an answer, but that's not really how teachers want you to say it. So I just happen to, so you can plug it into your calculator, or if you're a nerd, you can happen to know that cosine of 60 is 1/2. So 5 over 1/2, you flip the 1/2 fraction up, so it's like multiplying by 2, so x equals 10. If you're just learning this stuff though, I just use a calculator. Okay, and so Jed is teaching kind of like the, is it called a mnemonic? To memorize this cosine being adjacent over hypotenuse business, which is SOHCAHTOA. There's a separate way that you may have been taught to do this too, but this is the way that I kind of like more. So what SOHCAHTOA means is that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent, basically. It's just like a SOHCAHTOA is just like a way that many students have that memorized, but you can memorize it any way you like. Oh, I didn't even see that you asked what cosine is. Shoot. Okay, that's a good question. So you haven't been taught what cosine and sine are? Like, sine, cosine, and tangent? You haven't heard of any of those three, then I guess you do have to do it the other way that I was thinking. You don't? Okay. No, it's fine. It's just weird to me that you'd be asked some problem like this without being taught that. All right, let me try a completely separate strategy then. That's very weird. Have you heard of a 30, 60, 90 triangle? Oh, that's not a good drawing. Basically, that's 90 degrees, that's 60 degrees. So we can get this third angle by doing 180 degrees minus 90 degrees minus 60 degrees equals 30. And so that means that this triangle here is a 30, 60, 90 triangle, and they have special properties. And so if you were taught it to do it this way, I think the formula is that hypotenuse is 2 times that, which is 5 times 2 is 10, and that one is like root 3 times 5. So it's more of like a memorization, which is why I don't like it. Okay, so yeah, I guess you have to do the 30, 60, 90 triangle way, which I don't particularly like, but square root 3. Sorry, and I'm gonna Google this after to make sure that I'm not telling you the wrong formula, but I believe it's 5 times square root 3, which is just some crazy decimal. Let me verify that that's actually right, though. So I'm sorry that I gave you the wrong explanation at first. It's just, I hate the 30, 60, 90 triangle thing. It's a very specific case. I don't like memorizing things if I don't have to. So yeah, I did get the formulas right. So yeah, if the short side is x, the long side is x root 3, and the hypotenuse is 2x. You find if they only give you the 5 cubed number. I don't really mean by 5 cubed. If they only give you one side length, though, you can't do anything with this triangle, really. Like, if you weren't given that 60-degree angle and only that 5, you're just kind of stuck. You don't have enough information, I don't think. Does it matter what side length? I mean, this formula works for any side length for a 30, 60, 90 triangle. Hey, Jen. Oh. So you have to make sure that you're talking about the right, like, so here we were given, no, it's I don't think the hypotenuse has a name, but the other sides don't really have names as far as I know. So it's possible that you'd be given just the hypotenuse or just the long side. Yeah, no worries, Eberman. And you'd have to recognize that, I guess. Oh, wait, actually. Oh, okay, good. Okay, so rather than short and long side, I think across from 60 degrees and across from 30 degrees is a better way to explain it. So you might be given a different side and have to do the formula slightly differently. So like, let's say, say you have the same situation kind of, but instead you have just call it like 10. Why not there? So here this 10 is the long side, and we know it's the long side because it's across from the 60-degree angle. We can figure out the short side. So this is like the this one, it was already multiplied by root 3, I guess. So if you want to get the short side, you have to do 10 divided by root 3. Because that long side is one that gets multiplied by root 3. So if you want to get the short side, you have to divide by root 3. So that's like kind of the trick version of this problem. Where they might give you the long side or even the hypotenuse, and you have to reverse engineer what the other sides are based off the formula. And technically, teachers don't want you to have a square root in the denominator, so I mean, I won't go into it, but unless you ask, but there's a way that you can rationalize the denominator, they call it, but right, if it's not a right triangle, there is no hypotenuse. Why is a triangle 180 degrees but a full rotation 360 degrees? Basically, triangles and circles are different shapes is the best thing I can think to explain it. Like, basically each polygon, like, their angles sum to a higher and higher total, like, thing. So, like, a triangle adds to 180. A square adds to 360. A pentagon adds to like 720 or something weird. And there's a formula to get it for any like number of sides. So I know there's a specific connection between triangles and circles. I don't care about the actual number, Chad. It's 540, I guess. I was trying to say it for example. Yeah, so 720 is definitely too high of a guess, but yeah. Yeah, and that's formula there that Jen put. A bunch of other examples were replacing 5 with another number. Oh, right. Bluey. Sorry, are you blue or bluey or if you don't care then? I just want to make sure I'm not saying your name horribly wrong. But right, if you're given the short side and you want the long side, or sorry, and you want the hypotenuse, you always do like that number times 2. So if you have the same exact problem up here, but instead of a 5 you had say 7, then you just do 2 times 7 is 14 for the hypotenuse. That pattern is always true if you have a 30, 60, 90 triangle. And you made sure that this is the short side, which is across from the 30-degree angle. Either way, okay. Oh, it's actually 7? I didn't even look at it. Let me see. Oh. Oh, just the example in your thing is 7. Okay. So if we're good with that one, do you want to move on to the other one you posted? Sounds good. The answer is supposed to be CD on the test. I don't get how B, C, and D, A are congruent. What's the question in this one? Like, what are you supposed to find in this figure? The answer is supposed to be CD, Are they asking you like what the shortest side length is? Oh, I should read the title of things before I... Okay, sorry. If side BC is congruent to DA, that's not possible. Or is it? Which side is the longest? If side BC is congruent to side DA... So these can't be parallel lines. That was throwing me off, I guess. That's the only way they could possibly not be congruent. I think. Or wait. If side BC is congruent to side DA, they're equally long. Yeah, okay, Jed, you make a good point. Or do they mean... Or, yeah, or they're talking about like DA and BC, I guess, maybe. This is a very weird question. Wait. BC... Oh my god, I misread this. BC is congruent to DA. Then which side is the longest? BC... Okay, I was thinking of the wrong pairs of sides, I guess, for what are congruent. They still can't be parallel, though. Because 85 degrees and 95 degrees, I would think. Oh gosh, I hate it. It's drawn so it looks parallel, but I don't think they are parallel. Yeah, I want to apply that, Jed. It's just the situation is very weird. So if BC is congruent to DA, I don't see how the answer can possibly be CD here, unless we're talking about only about CD in AB. I agree with that, Jed. Like I would say that it's still part of my brain that a 95-degree angle here and the 85-degree angle here in BC and AD are equal in length, but I think they just can't be parallel. The options are AB, AD, CD, BC. So it is those outer sides. Thank you for saying that. The answer is supposed to be CD? How? See, I mean, Jed said the rule that I want to apply, which is the biggest angle is across from the biggest side. But that doesn't seem to be... Either there's an error in the question or that rule doesn't seem to hold here. I'm gonna put my mug away. Um, I agree that CD should be the smallest. I think there's no way, like, the only way to make CD bigger is if BC and BD, you extend them out, like, farther down. But then BC is just going to be longer still. Like, there's maybe some kind of argument that because things aren't drawn to scale here, that, you know, maybe it's hard to compare A, B, and CD. But certainly CD is smaller than, like, this CD has to be smaller than BC. It's just, I don't see how you get any other thing. That, honestly, legit, that would help me at least. Really? I need to draw this. $95, 42. $30.85. So I'm curious what those remaining two angles are. We can use the angles of a triangle add to 180 to find them out. 180 minus 85 is 95. 95 minus 30 is 65. I don't know if these are actually even helpful, but like, then over here, 180 minus 95 is 85. 85 minus 42 is 43. So if we look at it as are there problems of quadrilaterals that are helpful here? So if we remove that diagonal entirely, and we said that this angle is 95 plus 30 is 125, and this angle is 42 plus 85 is 127. Can we say something here? Maybe I'm too focused on properties of triangles, but we're working on GeoGebra now? Okay. I mean, this problem breaks it down into triangles also. And uses this angle side length relationship. I can't find a way to do it so far. Jed might come up with something with the GeoGebra. I'm still thinking about it. Times long class, so it's a big possibility. Oh, okay. Yeah, I don't get how you... It doesn't seem like CD can be the longest side here. If it somehow is, it uses some crazy property of geometry that I haven't heard of. And MadHab over on YouTube. The mileage of a tire has exponential distribution with mean 40,000 kilometers. Probability that one of these tires will last at least 20,000 kilometers, at most 30,000, at least 30,000. Given that it has been used for 20,000 kilometers. And, I would think smallest, yes, Bluey. You're not convinced that cheapest geometry possible? Okay. Thank you, Jed. Madhav, let me look up the exponential distribution again. Can it be quick, Jed? Because there's someone else asking a question too that I want to get onto. Unless something new comes up here, but do the other one first? Okay, sounds good. That's exponential distribution. I haven't worked with exponential distribution in a minute. It's just a special case of Poisson, though, I think. So the given it has been used for 20,000 kilometers thing is a little bit weird. Like, are we supposed to say, are we supposed to interpret like part A as doing 20,000 plus 20,000? Oh, or maybe that's just a part of the exponential distribution. That's what I'm thinking. Like, if only your second message was the entire question, I would think you just do 20,000 to infinity, as you say. But then you said the given it has been used for 20,000 kilometers part, and that's kind of throwing me off. I would think that I, I, I guess, yeah, you wouldn't add them together like I'm thinking. I guess you would do 20,000 to infinity. I definitely can't think of a better idea, at least. Um, yeah, I guess I agree with you there, Matt. Do you have like a further question on that one, or are you like okay with that? I'm sorry that I'm not more like confident, but I think it's the best that I got for you on that one. Okay, so you're also thrown off by the same thing. Because if it's already been used for 20,000 kilometers, isn't the probability that it's lasted at least 20,000 kilometers one because that's already happened? Because it already did last for 20,000 kilometers, so you know the outcome. That's the other interpretation, I guess. I'm trying to figure out if they wanted to do something different or just phrasing it weird. Given, I'm just stay with given and see what pops up. Because I don't even know like what to call that. I mean, I could Google the actual problem, I guess. Let's try that. I guess like I wish you said like 20,000 more kilometers or something like that. Mm. These similar like question things don't say that extra given part. They all want to like make me pay money to actually see it though, but yeah, I think the best advice I can give you is just to ignore that that like given it's been used for 20,000 kilometers part. So I can't figure out what you would do with that at least. So I probably just do the exponential distribution from 20,000 to infinity. So thanks for the question, but I think that's the best that I got. All right, Jed, do you want to talk? See, you're still in the Discord. Let me get that set up. Hey.
Hey, let me do a little share here for you. Basically,
Sounds
trying
good.
to prove that
I can't see the share yet.
Let's see.
Oh, sorry. Yeah, okay.
Trying to prove that shape cannot exist.
Right.
So this is a rough drawing. So basically what I've got is this point X, right? And what I've defined X as being any point I want. I've rotated that point 85 degrees to get to a point that creates this line G.
Okay.
And then I've picked, and then I've taken that line, that, some point on that line reflected around 30 degrees, and I basically get this triangle 85, 30, and whatever,
65.
Yeah. So I can create, basically any triangle that's that shape. Ooh, hang on. Did I just get something weird? So maybe the shape is possible. I just didn't play with it enough.
Oh.
Okay, so I didn't play with it enough. I've got to get a weird shape where
What?
that's pretty close.
Are these angles still true?
Yeah.
That's
So
more than 85 degrees with
well,
D.
this C is not correct. So originally when I had this in here, I had this X point as being a point on the, let me see if I can put it back to where it was. I had it as a point on the X-axis. Let me see if I can get it back to. Okay, X is now a point on the X-axis. I don't know what that last thing I undid is, but so X is a point on it basically controls the scaling, right?
Right.
So this is what I was getting when I was thinking it wasn't possible. So I basically took some point, reflected it, because I've got a couple of points that aren't shown, like D prime and that kind of stuff, but I reflected that X 85 degrees from across point D to give me this angle 85 degrees.
Actually, AD and
Right.
CB aren't even equal here.
Yeah, that's the problem
So
I'm running
that's
into. I can't
also
get AD and BC
okay.
to be the same length until I took X and moved it off of the X-axis. So if I do X equals 1, 0, then I get some weird stuff happening because I've hidden a few points. So I might need to bring those back into play here. Hang on, bring those points back on. So when I created this, I basically reflected this, and you can't see, where's X? B is the rotation of X 85 degrees from D. So whatever X is, rotate it 85 degrees up, and I get point B. So B and X should always be the same distance from D. And so what I actually did up doing is taking, so I may have drawn this wrong. I took this, then I took D and reflected it 30 degrees from B to get this point, and then set C is supposed to be the intersect, or D prime. What is it, D prime? I hit a line too, I think. Is it the B, X, and D? Oh, C, this right here is not correct. C is not supposed to be the intersection of X-axis and H. It's supposed to be the intersection of. So let me redraw this. I got to. It's not correct yet. But now that I can see, okay, if I move X off the X-axis, then I can get some points that are where the lengths of the two values, like that was pretty close, right? So CB and AD are roughly the same size. They're off by a factor of 0.01. I can probably get
But now the
closer.
angles are different.
No, the angle. Well, the angles are because this is not the right line. This line right here is not correct.
Oh, okay.
That line is supposed to be. I got to redraw this because I didn't figure that. I put X on there, and then I did these, then I made it where C is the intersection of the X-axis and B. But when I moved X off the X-axis, it should be, the triangle should be formed by, because the 85 you can see is not measured to C, it's measuring to X.
Oh, okay.
So the line, this segment right here, whatever this is a segment D. This should be segment D X or D. Well, if I do DX, I get that. So this is the point right here of intersection. So that's the 85 degree angle.
Oh yeah. So now the angles are good. Can we get
Well,
it
all
so
the
they're
angles
equal?
are saying fixed, and no matter how I move this, you can see that this is 85, this is 30, this is 95, and this is
Well, yeah, but
42.
C was out of place. You're getting
C
like,
is out of
yeah.
place. C should be the intersection of the DX line, which is what is this line? That's, I put that on last, F. So let me get rid of C here. I can delete that. Okay, so I just got rid of a length here. And I can say, let's create the intersection of this to this. that gives me my new point C. And then when I measure, find my measures here. Here we are, measure distance from B to C. Okay. So now as I move X around, so maybe I was right. Maybe they can't be equal. So I was right. Just that the measurement was a little bit off, but
Okay, yeah.
So yeah, BC is always less than AD. No matter where I move X, I can't get BC to be more than AD. If I go out this way, it gets noticeably higher. If I get down closer, you know, the difference, the ratio is gets closer, but I can't ever get it to be like, even if I go down,
Unless
see,
they
like
all
really
collapse
tiny.
on top of each other, but that's not. Yeah.
But the angles are all still the same, right? This is still 85 degrees. This is still 30 degrees. This is 95 degrees. This is 42 degrees. So no matter what I do, I can't get BC and AD to be geometrically the same or congruent, because it's just not possible if they share the same side BD.
Yeah, I definitely buy this as just an impossible shape.
Because if you have a triangle with two triangles that share a side and that have different angle measurements, the other side cannot be, you know, you can't guarantee these two sides are going to be equivalent. You can make a shape where maybe this side is equivalent to that side, but you can't make.
Bluey's asking if A, B, and C, D can be congruent. Can you measure those as well?
A, B, and C, D? Yeah, I can measure those.
Because, yeah, Bluey did mention that there's a different version of the same question that was the same shape, but they said the other sides were congruent, so
There's CD.
they might have both not been possible shapes.
And I don't know what, there's a D1 here that's kind of getting in my way. I'm not sure what, let me get rid of D1 here. Okay. So then I can make sure I'm grabbing the right segment here, A and B. Okay, so now we got the length of AB, we got the length of CD also being reflected. And all I'm doing is just changing the scaling around. But you can see AD and BC.
You know,
Like,
and the scaling shouldn't matter, I guess.
I mean,
it's good to like demonstrate it, but yeah,
you know, I can even turn it around backwards, you know, if I wanted to. But no matter what I do to this thing, this side is always. And let me put one more measurement on here, which is BD. Right, so that's the common side, right? But what we're going to see is that in this triangle BCD, no matter where it's shaped, because this is the bigger angle, BC will always be greater than BD and be greater than CD. Like there's nowhere I can make it where BC is a smaller length than BD or CD, which goes back to the statement we made earlier about the largest side has to be opposite the largest angle, because this is 85, that's 30, so this one's going to be 65 degrees.
Yeah, I was thinking you needed like equal angles for sides to be congruent, but like I guess I was taking the problem at its word, and it shouldn't have.
Yeah. So the ratio, what is it, law of sines, right? The ratio of this side to this angle is the same as this side to that angle and this side to that angle. What is the sine of this? Is it the sine of the angle to the length is constant for a triangle in that law of sines?
For the law of sines, yeah.
Yeah. So because this is the larger of the three angles, this will always be the largest side. Because this is over 90 degrees, this must be the largest angle of this triangle. But again, we can throw the other one on here, just wrong direction. Measure angle, DAB. There's the 43, there's the 42, there's the 95, which add up to 180. But again, this side will always be the longest. So if these two are congruent, in the world that can actually happen, and maybe the issue is we're dealing with two-dimensional space, and maybe that drawing is in three-dimensional space. I don't know. I mean, A doesn't have to be coplanar
or it's non-Euclidean
BCD.
space, yeah.
No, I mean A could be, if it's three-dimensional space, then it's 95 degree angle. You know, these two, they share a side, but this actually might be at a different. I don't know if that would make a difference or not, but so the longest sides would have to be AD and BC, and if they're congruent, then you can pick either one you want. But given the remainder of the sides, which one's the largest? It'd have to be the one opposite. Well, if you're dealing with this 30 versus this 42, this one's going to have to be longer than this one.
Mm-hmm.
Because that's a larger angle. Assuming you're not counting this. Because that's a 65-degree angle. So this would have to be larger than this one.
So Blue is saying, is there any formula to tell if it's wrong? Because it's also in the finals. I can get that point.
Is there a formula to say that is wrong?
I mean, technically there's like the triangle inequality if you have side lengths, but when you have angles, if you have congruent sides, you need congruent angles as well as kind of the general rule of thumb.
Well,
there may be some scenario where that's not true.
No, if they share anything in common, if they share a side, as in this case, if you have two triangles that have two congruent sides, it doesn't mean that the angles on the two triangles are the same.
I guess BD has different opposite angles.
But you could probably do something with the fact that this segment is, if you were to label this segment X, right? The length X, you don't know what it is. The ratio of X to sine 65 degrees, right? Which is the opposite angle from that, would have to be the same as this 85 to that, right? Sine of 65 over this is equal to sine of 85 over that. Is that fair to say?
Yeah.
Okay. And then by the same token, the sine of 43 to that same value has to be equal to the sine of 95 over that.
I think so, yeah.
And then you can prove, so then you have to say, okay, well, if that is equivalent to, if those ratios are the same, then you should be able to figure out what X is based on those two unknowns, right? You could solve for the length of X given. Well, actually,
we don't have a side length in the first place.
This is a
we
constant.
can maybe get ratios, but.
And that's a constant, right? These two are the exact same thing, right? So you've got two formulas with two unknowns, or two equations with two unknowns, right?
Well, you never know how the shape is scaled, though, if you're not given a side.
Doesn't matter. If you know AD and BC are congruent, let's call this side right here.
I guess if you're using their congruent.
Let's call this X. AD is X, right? BC is also X because they're congruent, right?
Yeah.
Okay. Let's call segment BD, let's call that Y. Okay. So then we can take the sine of 95 over X is equal to the sine of 43 over Y.
Although I just remember Bluey doesn't have sine, cosine, and tangent.
Well, I'm just saying, if you wanted to prove that this shape cannot exist, I think you could do it with sine 95 over X equals sine 43 over Y. And sine 65 over Y is equal to sine 85 over X. You have two equations, two unknowns, and you can prove that there's no values of X and Y that will satisfy both equations. If you feel like doing some, I could bring up Wolfram, I guess we could hash it out.
I mean, I'm convinced this shape isn't possible. Like, I'm just trying to help out Bluey, like, because how they get CD even it's wrong, because it'll be on the finals.
Yeah, I think if you're talking about, if this comes up on a test, you can say that because this angle is 95 degrees, this side must be the largest side of this triangle ABD. So AB cannot be longer than AD, and BD cannot be longer than AD. This has to be the longest. The same thing can be said about this triangle. This is 85 degrees. If that's 30, that makes this 65. And because the longest side of the triangle has to be opposite the largest angle, BC has to be the longest side of this triangle. So BC is greater than CD. So CD cannot be the largest length in this shape. AB cannot be the longest length in this shape. And what was the other option we had? The two sides we were given, AD and BC. So those have to be the longest length. And because they're congruent, they're equal. So therefore they are both the longest shape, the longest side.
Yeah, it's okay, Bluey. I don't know how you. But it seems like CD should be the shortest side, and I don't know how you would. Like, I can't think of an incorrect way to justify CD as being the longest. Unless you really just had the rule backwards.
Yeah, because you can't get AB to be shorter than CD.
It,
You can.
like, it's something to ask your teacher about, because
Yeah.
this just isn't possible. And hey, Charlie stuff.
This is longest. This is second longest. This is shortest. This is longest. This is second longest. This is shortest, because 43 and 42. So this has to be the shortest side of this triangle. But as far as the ratios of this to this, I guess this would have to be bigger than this, because that's a 42 and that's a 30. And because this side is constant between the two triangles, you know that this one's going to have to be shorter than that. I don't know if you can, what theory you would use. I mean, I guess it's still that whichever angle is bigger, that opposite side is bigger.
Yes, so I guess like you just say the opposite. Like if they're asking for the longest, just give them the shortest. That's the only like consistent thing that I can think of to do that's wrong, but might get the answer that they want. Yeah, no one is asking a question right now, at least. I guess Charlie Charles over on YouTube. If you do have a question, please let me know. If you're just here to hang out, that's cool too.
We just like hanging out and chatting about things, looking at movable charts when there's nothing else going on. But that's why I was like, take care of the other problem first, because this is like fun. But yeah, I mean.
Yeah, sorry, Blue, but I think you're just giving an impossible problem here.
If you were given two separate triangles that weren't connected, if two isolated triangles,
you don't know their scaling.
You wouldn't know their scaling, but you do know that AD and BC are congruent, so they are the same.
True.
And because they are both the largest sides of their respective triangles, they would have to be. They're it's 95 degrees here, so this has to be the longest side of this triangle. This
but
is 85.
If they're congruent, then
so again,
of that
AD
triangle.
and BC
okay, yeah.
would be the longest lengths, even if they weren't connected together on segment BD.
Right. Yeah.
If they were two completely separate triangles, because you have the fact that they're congruent, that AD and BC are congruent, they have to be the longest sides of the entire shape.
Mm-hmm.
Because of the angles.
All right. Well, yeah.
Technically, ABD is an obtuse triangle, right?
Yeah.
So so this side opposite the obtuse angle has to be the longest. I mean, that's just property of an obtuse triangle. The side opposite the obtuse angle is the longest side of that triangle.
Right.
This one is not obtuse, but you know that this is the largest angle because of math.
Because of math. QED.
Well, because 180.
No, yeah.
180 degrees.
I know, yeah.
Yeah.
But all right. Thank you for looking into that.
Yeah, it was a fun graph to draw. I was trying to think if I could do something with a circle to say, okay, well, this segment has to be the same as this segment, but once I started putting together, I was like, there's no way that AD and BC could actually be congruent.
Mm-hmm.
Unless congruent was the wrong word.
Mm.
They couldn't be parallel.
Oh, actually, Blue. Oh yeah, hey, well, welcome in, Blue. We're definitely glad to have you in the community.
Absolutely.
But just are you doing the math in English or is this a translation? Sometimes that does make things a little bit weird. And sorry, what, Jed?
Now I was going to say, is congruent the actual word used in the problem?
That's the actual word that Louis used when they posted it. It's in English. Okay, I just want to make sure.
Okay. Yeah, I would. I mean, you could, if you want to, question the instructor or whatever. It's like, how can AD and BC be congruent given the law of sines? And see what they come up with. Kind of. Of course, they might start expecting more of you after you say something like that.
Yeah, expecting Bluey to already know the trig formulas and law of sines and all that.
I mean, that would be a fun exercise, actually. If you don't have anything else going on, you want to do some law of sines stuff.
That's not fun for me.
is to actually prove that AD and BC cannot be congruent in that. And that would give Blue something to screenshot or whatever and take back to the instructor. You know, just using the two formulas to unknowns. Oh, it's a bot? Okay. Never trust
You
a
have no
bot.
teacher. It's a... Oh, is this ChatGPT? Yeah, don't use ChatGPT for anything with math, Bluey. I in my opinion, don't use it for anything at all, but don't use it for math. It's a program? Okay.
Well, even if it's a program.
If it's... Yeah, if it's like an AI or something like that, it's probably wrong.
If it's creating those angles like randomly, and then assuming AD and BC are going to be congruent, that's just not possible. Whoever designed that program is a programmer, not a math guy.
Yeah. Especially like having the other problem arbitrarily saying that A, B, and CD are now congruent definitely seems like it's a big leap.
Well,
It's online
if
school.
A, B, and CD are congruent.
But like taking the same exact shape and just arbitrarily saying that the other two sides are congruent now instead. That seems like a
I wonder if that's even. I wonder
lazy.
if that's possible. I don't think that's possible.
That's why Blue was asking about A, B, and CD before.
Yeah, because if they're congruent, then the angles would be different. Yeah, again, they'd be.
Yeah. So I'm sorry that you're
I don't
stuck with that online school
Yeah.
thing, Bluey. They're giving you some bad questions.
Anyway, I'll leave it up to you, Don, whether you want to do some law science stuff. That's
right.
totally on you. But like I said, that might be a fun proof that AD and BC cannot be congruent because of the relationships of the sides.
Oh, you know what? I think it'd be like a two-step proof. You would end up with something like sine of 95 equals sine of 85, and we know that can't be true.
No, I mean, it's a ratio, so it's not going to be. It's the
Right,
ratio.
you can eliminate things if you know they're congruent.
This to this. Well, you're not eliminating. You're basically making this one unknown, which is equal to that.
And if AD and BC are congruent, then you can get rid of those side lengths too.
You're not. Well, you're not making any assumptions about the similarity of this triangle to this triangle. You're saying that the ratio of this side to an x is the same as the ratio of this to
but
y.
They're both equal to that same ratio, so you can equate them.
You could solve one for y and then plug that in to get a value for x that cannot be defined, or some. Like I said, you end up with two equations, two unknowns. How you want to solve that? You're basically going to eliminate one of them, right?
Well, it's going to be if you don't assume that AD is congruent to BC, then yeah, you're right. But if we're just trying to prove that it's impossible if AD and BC to be congruent, then you can get a contradiction.
Well, I mean, so the unknowns are AD and BC are both x, and BD is y. Those are your two unknowns, and your equations are the law of sines for the ratios of one triangle.
Okay.
I'm
going to show you on the board. So I think this is like it'll be hard to hear me on Discord, but.
Oh, that's fine. Can you still hear me?
Yeah.
Okay, you still got the drawing up there.
So by law of sines, sine of 95 over AD is equal to sine 43. Oh, maybe, okay. 85.
I think you're seeing now, my two unknowns are AD and BD, right?
Sine of 65. Okay, I guess you're right, Jed. I forgot that you're always right. I thought these were the exact same, so you just be able to equate those two with each other. But no, it's different signs there. So.
But AD and BC are the same, so you can sub one for the other.
That's true. I just don't know how you proceed from there, though, I guess.
Yeah, I would probably solve one side for, solve for BD on one of the equations, plug it into the other one, and then prove that if AD equals BC, there's no solution. Right?
I guess, yeah.
So BD would be equal to AD times the sine of 43 over the sine of 95. Oh, you're doing the bottom one, okay.
Oh, yeah. But it should all be the same.
Yep. And then you could actually solve the first one for the same thing too. Probably be easier than just set them equal to each other.
Oh yeah.
Rather than try to do the division by division.
Sine 45 over sine 95 times AD sine 65 over sine 85 times, and instead of BC, I'm going to say AD. And these two are almost certainly not the same.
Yeah, the only value for X would be 0. That's the only place where they're where they're equal to each other. So that means that AD and BC would have to be both length 0, right?
Right, yeah.
Which is I think that gets the trivial, right? Yeah, I have it right there in the Wolfram Alpha.
Yeah. And Charlie, sounds good about your homework. Patient, sure. I'll wait until I see the function. And hello, Giovanni. How's it going? So yeah, I guess actually not too bad if the law of science prove that this isn't possible.
If they intersected anywhere besides this, and that X would be the length of AD and BC. But because they only intersect at point 0, that means the length of AD and BC would both have to be 0. And because of law of sines, every side of that triangle would have to be length 0.
Mm-hmm.
So actually, the correct answer to that equation is all sides are equal length. they're all the longest, they're all the smallest, they're all equal to 0.
Mm-hmm. There you go.
So I guess in response to that, I guess CD is one of the longest sides of that shape. So ChatGPT technically wasn't wrong.
I guess, yeah.
Any answer is true. All of the above.
And Giovanni, sure. Feel free to post your question in chat, or if you have like a picture or something, you can put it in my Discord. I might let you go now, Jed, because there are 2 people over on YouTube
Absolutely.
who are going to be asking questions.
Yeah,
soon.
I'm not lurking YouTube. I should be over there. Thanks for the chat.
It's up to you, but yeah. Thanks for investigating that.
Bye.
See ya. You're Italian? Well, that's not a problem with me. I can use a translator and hopefully can figure out what the question is. So yeah, feel free to go and post it, and I'll try it. Okay, and then patient 67, I'm still waiting to see your thing. Take your time typing it out if you need it, but I just want to make sure that you know that I haven't like forgotten about you. You binary logical operators like bitwise XOR and bitwise AND when it comes to regular math. I don't see the use. There probably is a use, but not the type of math that I typically do. Confirm what you're working on? Oh, okay. While I wait to see Giovanni's and Patient's questions, I guess I'll look at my DMs on Reddit. Hey, Zach. How's it going? Just interesting things. Alright, this pretty fun polar curve problem. See what the person said back to me. Okay, sounds like they are just saying thanks. And they're putting my explanation in their own words, which is perfect. Why is inverse sine of -1 negative pi over 2 and not 3 pi over 2? That's a great question. And the answer is that it's completely arbitrary. That's just by convention, Zach, basically. Painaflex, thanks for the follow. I'll actually draw it for you here for why they do it like that. Okay, so the graph of sine, just normal sine, not inverse sine, looks like that, just, that infinite wave going left and right. And if you remember, like, your rules with inverse functions are the reflection across the line y equals x. So if you take this sine wave and reflect it across that y equals x line, you actually get a vertical sine wave. I think it's something like this. And if you remember, you might have been taught like the vertical line test for whether something is allowed to be a function or not. And this certainly breaks the vertical line test because you have multiple y values for one x value, and that's not allowed in math as students normally learn it. So you have to cut off everything that breaks the vertical line rule. So they normally cut it off so it's symmetric around like 0, 0, like this. And that's why inverse sine has that like shape like that. And that's why inverse sine of -1 is negative pi over 2 because you're down there. You could have cut it off, up here and be perfectly valid too. You could take like, that portion of the sine curve up there, and that'll be your 3 pi over 2. But just by convention, people always take that portion of the inverse sine curve. So if you're in a situation where you get minus pi over 2, but you want the 3 pi over 2 equivalent angle, you need to do some unit circle stuff. How we define the formula and the principal branch of a function within. No problem, Zach. Is there a way to remember trig values? Are you talking about the unit circle? EM can't shoot? I can give how I remember it. And tired student, can you please explain the different polar graphs from sine and cosine? Ooh, I'd have to Google that. Like the actual, like, are you talking about like the names of the polar graphs, tired student? Like limicons, cardioids, and that type of stuff? How it's graphed, heart, etc. Okay. I'm going to address EM can't shoot's question first, and then I'll get to yours, tired student. Anaflex, do you know the pumping limit? I haven't heard of that. No, I'm sorry. And Phobo Stream, thank you so much for the raid. You're seen playing math. Oh, we're doing some actual math, or are you doing some more game dev stuff? Either way, thank you so much. Hey, Anders. Hope your stream was good. Or, sorry, Phobos, I hope your stream was good. Anders, if you stream, then I need to tune in, but... Hey, Phobos. Jack says, hi, can you help me with the demonstration of the point of the Torricelli and Fermat 3 streets problem? I've never heard of that, Jack. I'm sorry. I don't think I'll be able to help you with that. Oh yeah, corrupt converter. I can make for a good stream. You always seem very enthusiastic about it, and that's that helps. Okay, so EM can't shoot. You asking is there a way to remember trig values? You haven't said otherwise, so I'm interpreting that as the unit circle values. And how I memorize the unit circle is I just memorize the first quadrant here, so between 0 and up to pi over 2. Someday maybe. Ooh. Well, that'd be awesome. Only Italian high school could ask for something like that. Yeah, I could try to Google it, but that's not something that I have studied before. But there's a few who have asked questions before, so I want to try and address questions as they come. So I just have this part memorized, and if you memorize the first quadrant, you can get your way around to the other 3 quadrants by adding basically, you know, if you want to get from pi over 3, if you need the equivalent pi over 3 angle over here in quadrant 2, you would have to add pi over 3 to it, which I guess, you know, it's something where I do it very, very like visually, I guess. It's like this pi over 3 angle and that 2 pi over 3 angle are very related. The only difference is this is positive 1/2 and that's negative 1/2. And you can work that out based on the quadrant you're in, because quadrant 2, x's are negative, y's are positive. And like, you know, to go from pi over 4 to 3 pi over 4, you add pi over 2 now, and you have to make the x negative. So you can kind of like rotate your way around the unit circle. From quadrant 1 to quadrant 2, it's a little bit weird, but like, actually, it's kind of weird in general. To be honest, I usually just have this like offhand, so I don't have to do it very, very often. So you're currently studying measure theory, you have a math question. How do you find a will to live? I'm not studying measure theory. By interpreting with the unit circle as counterclockwise from arc of 1, 0 of length x. Fair enough. Hey, Ben. Or math, yeah. So, yeah, EM can't shoot. I just make sure you have the first quadrant down. It's like, there's only a couple of like moving parts here, I would say, like root 3 over 2, 1/2, and root 2 over 2 are the numbers that you have to like have memorized. And you know that pi over 6 is a little bit further away in the x's, but it's not as high up. So the root 3 over 2 must be over here and must have a 1/2. Whereas this pi over 3, it's higher up and not as far to the right. So the 1/2 is the x and root 3 over 2 is the y. So it's kind of, I don't have a good, like, that much better explanation of that, unfortunately. I hope I interpreted your question right in the first place. Okay, so after EM can't shoot S that, tired student asks, can you please explain the different polar graphs from sine and cosine, how it's graphed or how it's shaped? So sounds good, Zach. If you're willing to, if you've heard of a site called twitch.tv, there's quite a few math streamers over there who are also available to answer questions. I'm not aware of any on YouTube. They might be out there besides me. Oh, okay, good. I have updated that command. But yeah, my normal days are Tuesday, Thursday, and Saturday, starting 2 hours ago, more or less. Okay, so yeah, tired student, you asked me about graphing polar graphs. So, tired student, I guess, like, are you asking if you have if you're just given a generic polar function, like how would I go about graphing that? Oh, okay, good. So that's a little bit easier if you're matching the equation to its graph. So graphing things in polar is kind of tricky. If you are given the equation, you have to match it with the graph, though. What I would do is go for the easiest angles to calculate and verify those. So like if you're given 3 plus 3 cosine theta, I would check what the values are at 0, pi over 2, 3 pi over 2, and I guess 2 pi is pointless, but like just start with the easiest things to get actual numbers for and verify those points. So, you know, 0 pi over 2 pi and 3 pi over 2. And if there's still like, if you graph in the rectangle way first, it's going to be hard to graph things with rectangular coordinates. I would stick only, personally, when I have a question like that, I'd stick only with polar coordinates and just try plugging things in for theta. So actually, I'll show you on the board. I wouldn't worry about the normal cosine graph for a question like that. Maybe there's a way that you can do it and have it be useful. But I use a similar process as how I go about graphing a normal Cartesian function with plugging in test points. It just is going to look a bit different in polar. So if you have r equals 3 plus 3 cosine theta, let's plug in some test points and see how far we can get with the easy ones. So for theta, let's do 0, pi over 2, pi, and 3 pi over 2. Cosine of 0 is 1, so 3 plus 3 is 6. Cosine of pi over 2 is 0, so 3 plus 0 is 3. Cosine of pi is negative 1, so we get 0. Cosine of 3 pi over 2 is 0, so we get 3. And if we were to go out to 2 pi, we come back around to 6. So we have a table of points here, and we can eliminate any graph that does not contain these points right off the bat. So theta equals 0, 6, just like, you know, call 6 that far out arbitrarily. At pi over 2, we're at 3. At pi, we're at 0. At 3 pi over 2, we're at 3. Then back around to 2 pi, we're back at 0. So I would guess it's a cardioid that looks, you know, something like that. So I picked out a shape like that, and if I needed more test points, I think the next easiest thetas to plug in are pi over 4. and like 3 pi over 4 and stuff like that. But hopefully, even just from those angles there, you should hopefully have a good idea of what you can eliminate and like, you know, like what's good and bad. So I hope that makes sense, tired student. Just do those test points and see how far they get you. And if you need more, just keep trying more. And I hope I got that graph of the polar thing right. I'm pretty sure I did. Yeah, okay, good. Sub? Oh, well, thanks so much, Zach. Shoot, I keep on forgetting to get alerts for YouTube. It's kind of hard. YouTube doesn't make it easy. But thank you. Okay. So that addresses tired students' question. So way earlier, Giovanni Impatient mentioned having questions. I still haven't seen it, but I'll happily switch over if I see it. Just making sure I'm not forgetting wins. And so, okay, so Jack 117. You're asking about Torricelli and Fermat 3 streets problem, which I never heard of. Well, let's see if it's simple enough that I can figure it out. Demonstration of the point of it. Geometry which aims to minimize the addition between the distance of one variable point in the triangle and its vertices. That's like an academic paper. Oh, finding the point inside a triangle that is the minimum distance to its 3 vertices. Interesting. Wouldn't that just be the, I forget what that's called, but whatever that, like, median middle point is? Maybe it's not that simple, though. In center, yeah. Oh, I guess that's when they do it with weights. Really? This isn't a simple problem? Like, I feel like the answer... These are dangerous words, but isn't the answer to the question obvious? That it would be the in-center? And you take, I guess, the average of the coordinates of the 3 points? Although, I guess... No, yeah, you're given the coordinates, so... Really? Maybe it's not the average. But recently, a Russian mathematician published a paper in April 2014. That's how you know the site hasn't been updated in a while. 1 is not a prime number, right? Correct. 1 is not a prime number. Don't ask me why, though. I don't know. I could Google it if you're curious why. I don't know if that's a convention or if there's an actual reason for it. But I believe 2 is the first prime number. Okay, now why isn't 1 prime? find a number is prime that's divided by exactly two numbers. It's like 13 is divisible by 1 and itself. 1 is only divisible by 1, though. So it's only... One should be ultra prime then, you know? Or... Okay, so it is more of a convention thing. Like, mathematicians today have decided to say it's not prime. You could validly make some other number system where it is prime. In-center and orthocenter? Nope. Okay, apparently there's 4 different middles of a triangle. Okay. So maybe it's not that simple. I normally stream Tuesdays, Thursdays, Saturdays, Tired Student, starting 2 hours ago. So it's 1 o'clock Pacific time is my start time, which means Eastern is what, 4? I think it's plus 3 hours, so 4 EST, yeah. All right, see ya. Thank you for the question. All right. Have they actually said this? I mean, oh, it's the same exact paper. Makes an angle of 2 pi over 3 with any two vertices of the triangle. I feel like that fits like the circumcenter, one of the existing definitions of the center triangle, right? Hey, Sadra Caroline? I didn't see what you posted, but if you're saying hi, if you have a problem, please feel free to do so. If you're just hanging out, that's cool too. I'm gonna use the bathroom quick, I think. I don't know what's happening with this thing, but I assume Jackson's here still anyway, and I don't really get what's happening here, so... yeah, I'm gonna put my BRB screen. I'll be back in like two minutes. And, thanks everyone who's been here so far. Okay, we're back. Ben with a 5 watch streak. Wow, thank you. Holy crap, dude. Okay. So as far as I know, there's no questions waiting for me from people in chat, and if I'm wrong, please correct me. Come on. So I was looking at this person's reply, just kind of out of curiosity for how they interpret the problem. Okay, cool. So, I think what I want to do at this point, definitely still math. I'm not like switching away for math, but I've been kind of curious about Penn Center's reading group for abstract algebra. I was thinking, like, you know, maybe if there's some downtime on stream, I might try and go through some of the book. You know, I think I'll do. So Penn Center is saying that we want to go through chapter 0. I forget if it's, wait, for Friday stream, for Sunday stream? I don't know if it's this Friday or next Friday and Sunday, but just start looking through chapter 0 and some of the questions there. Where is this saved on my computer? Put it on my desktop. Now, can I open this in Opera? Is that going to be a thing? No? Okay, Opera doesn't like PDFs. So let me come over here. Close out of that. Ugh, it's just so annoying. Desktop. Okay, there we go. Contemporary Abstract Algebra 9th edition. I am not a fan of a little bit that I do know of abstract algebra, but I feel like I should know it. So I'm kind of like begrudgingly looking through this, and I'm just going to give it a good try. And this one was a question I'll happily like switch away as well. But... Alright, so let's look through the notation first, I guess. I've been thinking about it, and there's like, so oh no, no worries. Because I'm really not enthusiastic about learning algebra, but I feel like I should know it. So I figured if I have some downtime on stream, I might at least try to at least start looking through chapter 0. And see how much I can keep up with it. Equivalence class of S containing A? Yeah, I don't even know what that is, but I assume we'll see more on page 18. Cardinality, special sets, multiplicative group of positive rational numbers. Assume we'll learn more about that. Star non-zero. Okay, so star just removes 0. T divides S, T does not divide S. GCD, LCM, absolute value, phi of A, image of A under phi. Okay. Mapping of A to B. Oh, that's how you say the arrow. Okay. B maps A to B. GF alpha beta is a composite function? Okay, that's gonna be weird for me. Should use those as constants, I guess. Maybe I shouldn't worry about all this stuff. Maybe we should refer back to this page as we encounter things. Okay, yeah, there's a lot of notation here. Yeah. I didn't think that I didn't think there'd be so many notation things to like look through. So for chapter 0, oh, this is quite a few varied things to look through here. Let's just get into it, I guess. I don't know if this pre-word is that important. Back of the book, skeleton solutions. Hints to the odd numbered exercises. All right, properties of integers. Well-ordering principle. Take it as an axiom. Okay. Every non-empty set of positive integers contains the smallest member. Okay, fair enough. The concept of divisibility plays a fundamental role in the theory of numbers. We see the non-zero integer t is a divisor of an integer s if there's an integer u such that s equals tu. In this case, we write t divides s. You know what? See, this is... We're just talking about why 1 isn't prime. To me, 1 would fit the definition of prime here. Because one's only positive divisors are 1 and itself, which happens to also be 1, but... I don't know, I should not question. I mean, I guess they haven't said whether they consider 1 prime or not, but I assume they don't. If an integer s is a multiple of integer t if there's an integer such that s equals tu, which is equivalent to t, the divisor of s. As a first application of well-ordering principle, we establish a fundamental property of integers that we will use often. Division algorithm. Let a and b be integers with b greater than 0. Then there exists unique integers q and r with the property that a equals bq plus r, where 0 is less than or equal to r is less than b. Oh, really, Anders? Topics are in the syllabus of the course you teach. Sounds good. I mean, for stuff like this, I recognize, like, I'm recognizing this stuff so far. I'm only on page 3, but it's not too bad yet. But I might have to take you up on that. Unique integers q and r. See, I mean, this is basically breaking out a division with remainders. The fact that it's unique, I mean, I haven't really like ever thought about before. With the existence portion of the theorem, consider the set a minus bk where k is an integer and a minus bk is greater than 0. Okay. If 0 is a member of S, then b divides a, and we may obtain the desired result with q equals a over b. Oh, Kelvin or Kit? I don't know how you're supposed to say that, but find the linear approximation of the function f of x equals root x at a equals 9 and use it to approximate the numbers 9.1. Or square root 9.1. Are you using Taylor series? Or like are you in a calculus class? Calc 1? Oh, so if you don't know what a Taylor series is though, which that's okay. I just would phrase my explanation a bit differently. All right, so let me go over to the board. So yeah, you're getting a linear approximation. So yeah, if you go into Calc 2, I think you'll learn this idea more formally and you'll be able to do other polynomials than just a line. But thankfully, a line we can work out intuitively. So find the linear approximation of the function f of x. Hey, Henrik, and hello, Zumedo. Am I saying that right? So we have f of x equals square root x. We're going to make a linear approximation. At a equals 9 for, I guess 9.1. I know it's a bad way of phrasing the question, but that's basically what was happening. So I'm going to draw the graph of square root of x. It's a parabola facing sideways, and I'm only doing the upper half. So at a equals 9, we have the point 9 comma 3. And we're going to go just, we're going to use the tangent line as our approximation. So we want to find the graph of the tangent line at x equals 9. And then we're going to plug in 9.1 to that line with the idea that it's going to be pretty close to the actual value of the function. Yes, Zumido? Okay, so if you have a question, feel free to post it in chat, but we're going to this question from, I still don't know how to pronounce it, but I'm saying Kevin. How about that? Even though it's clearly not Kevin. So let's start by getting the equation of the tangent line at x equals 9. So we need to find f prime x for the slope of the tangent line. So if you know your power rule, square root of x is like x to the 1/2. And so when we apply power rule, we bring the exponent down 1/2, and you do the exponent minus 1. So 1/2 minus 1 is negative 1/2. And a power of negative 1/2 can also be written as 1 over the square root of that. So I'm going to write it like this. But either form is completely fine. So we have the slope of the tangent line for any point x, but we want the slope of the tangent at x equals 9. So let's plug 9 into this. Square root of 9 is 3. So we have 1 over 2 times 3 equals 1 over 6. Great. So we have a point, we have a slope, we can make a line with that. So y equals, I'm going to plug it into y equals mx plus b. There's a different form of a line that's a little bit easier, but that's the way that most students learn. So m is, the slope is 1/6 x plus b. And then for x and y, we'll plug in the point 9, 3. So y is 3 times 1/6 times x is 9 plus b. Now solve that for b. So 1/6 times 9 is 3 over 2. B equals 3 minus 3 over 2, which is just 3 over 2. So the slope of our tangent line becomes y equals 1/6 x plus 3 over 2. Now the only thing that's left is to plug in 9.1 to this tangent line, and that's our approximation for the square root of 9.1. So y equals 1 over 6 times 9.1 plus 3 over 2. I call that work for a calculator personally. So let's do that. 9.1 divided by 6 plus 3 over 2. So the approximation that we get is 3.017, I guess, depending on how you want to round it. And just as a sanity check, we can get the actual square root of 9.1 here. Oh, hey, that's a pretty good approximation. It's accurate to 4 decimals. So I hope that makes sense. Please let me know if you have any questions, though. And Henrik, you're saying iz squared minus 6 plus 8i equals 0. This question was from your exam. You don't understand what to do. Zumeto says substitute z equals x plus iy and solve for x and y. No problem. Thank you for the question. Let me know if you run into anything else. You went down the battery, you try to convert everything to polar form and divide by I. Oh, that could get tricky. Cool. We can try to work that out, Henrik. I assume that Zumeto is giving the right idea here. But I assume you're going for polar form because of the power of z, which doesn't seem like a bad call, but if it's only z squared, maybe it's not that bad to just square it and deal with the consequences. Dude, this eraser, it might be saturated. It's not erasing very well anymore. I don't think it ever did, to be fair. Okay. So Henrik, you have IZ squared. Was it plus or minus or minus 6 plus 8i? Equals 0. So yeah, I'll show you what Zumeto said, and sub z equals x plus I y. So we get I times x plus I y squared minus 6 plus 8i equals 0. Multiplying that out, you get x squared. Gotta be careful. Oh no, that one's okay. Plus 2ixy, I guess. Minus y squared. Minus 6 plus 8i equals 0. Multiply the I in now. Minus 2xy minus iy squared minus 6 plus 8i equals 0. So let's get the not xy's onto their own side. The real part over here is minus 2xy. The imaginary part is right? If we factor out the I, equals 6 plus 8i. Now equate the real to the real, the imaginary to the imaginary. Minus 2xy equals 6, and x squared minus y squared equals 8. And I think you want to isolate x or y here and plug it into the other one. You could do it the other way around. That seems painful, though. X is minus 3 over y. I think that's good. So let's plug that in up here. 9 over y squared minus y squared equals 8. Multiply everything by y squared, I guess. Hopefully this factors. It does. Okay, good. Y squared plus 9 and y squared minus 1. I wonder if we're going to get potential fake solutions here, so we should maybe check them. But from the first one, we get y is plus or minus 3i. Yeah, and from the second one we get y is plus or minus 1. Well, yes. Yeah, okay. Make sure with complex numbers there isn't something weirder, but I think that's okay. So are there 4 solutions to this? Maybe? Because maybe we... That can be correct. Thank you, Anders. So I guess we can get our pairs of solutions. It's weird that we get 4, but I guess that is what it is. So x, y can be... I'll start with, I guess, positive 1. You plug in positive 1 there, you get negative 3 for x. With negative 1, you get positive 3. With positive 3i, you get minus 1 over I, which you can rationalize, times I over I. Negative 1 on the bottom, that's just I? Okay. And then minus 3i. I assume we're going to get negative I here. Yeah, okay. I think that we get 4 solutions. I don't think there's anything that would give us possible fake solutions. Can you use quadratic? I think quadratic formula is fine. I don't think you have to use it here, but you could. So I think quadratic works for imaginary just as well. Polyregion, how do you learn to factorize polynomials? If you know like the AC method, it's sometimes called, or like, you know, what multiplies to A, like what multiplies to AC and adds to B. You basically do that method a million times, and then you can factor things in your head. You got square root 1200. Oh, that seems off. That by I3, I mean that's a solution. That's like an XY pair that works. Let's give it to Wolfram Alpha. And Jeffrey Pelton on YouTube, for a following vector convert from X and Y to magnitude and direction. I can definitely do that, Jeffrey. Just let me get to the bottom of this question first, and then oh, it does, Anders? I guess, yeah, maybe it's bad form to write it the way that I did. Oh, yeah, it'd be Z equals, we should write, well... Yeah, wait, how does this work? Oh, yeah, oh, God. Yeah, I did that poorly. Why does Wolfram, do we get redundancy? Okay, you know... That's actually, I forgot, Z is X plus IY, so we should not write it like that. See, this is where I'm not too good with complex numbers, so I end up doing stuff like that. So yeah, X is the real part, Y is the imaginary part. Does it make sense to get a Y that's also imaginary? Is that why we throw those out? Because Y has to be real? Interesting. Anyway, if Y is positive 1, then X is negative 3. So negative 3 plus I. And then if Y is negative 1, X is positive 3. Is that what Wolfram said? No? Oh wait, it's scaled different maybe in Wolfram. I don't know. Okay. Yeah, so we would eliminate those. Because Y is restricted to be real. Thank you for that, Anders. But is it because I did the sub different? Why does Wolfram get negative 1 plus 3i and 1 minus 3i? I think there's a difference in scaling. It's the same number, right? I guess we can plug in the actual solution that I got and see if it gives a true statement. They're just not the same? Okay, well then I did something wrong. You mean like 46? Yeah, Chad, that is a pretty complex number. Red alert indeed, Henrik. Sixth line. One, two, three, four, five, six. Oh my God, Anders. You're right. Minus, minus, minus. Minus. Minus, plus. I had those backwards. See, the only solution now are y equals plus or minus 3. And that is going to match what Wolfram Alpha got. So z could equal, if you plug in positive 3, you get negative 1 plus 3i. Or z could equal, if you plug in negative 3, positive 1 minus 3i. And if that doesn't match Wolfram, then I quit math. All right, my math career is safe for another second. Right? Minus 1 plus 3i, 1 minus 3i. Okay, that's how you do it. Thank you for the help. Saves, Anders, saves, zoom meta. Give the idea for the initial thing. You define the differential equations part though? Oh, that's good to hear though, Henrik. Okay, so Jeffrey Pelton, I see that I still see your question there. Are you still here? I'm happy to do that. And I mean, I'll work it out regardless, I guess. So you have the vector -7, 8, and you want to know the magnitude and direction, it sounds like. So we can definitely do that. Oh, could it not before? I don't know. Apparently I haven't given you a save before, which sounds weird. Oh my God. It's not even erasing. Look at that. It's terrible. Ugh. Okay. Is my name Andrew in real life? No, it's Don in real life. Curse Marcus Phobos? Yeah, exactly. I was talking to Anders. Okay. I've heard like Andreas. Or I guess Andrea is possible too. I think it's the question that Jeffrey is asking. Andres. Oh, that's cool. I didn't know that. Oh, the music is cutting out again? No! Why does it do that? I hate that it does that. Sometimes just pausing it and replaying it is enough. Tell me if it's still happening. And if it's still happening, I'm just going to cut the music off, I guess. Still doing it? All right. No more music for now then. I don't know why it does that. It's so annoying. I can't find anything on Google about that happening. Because on my end, it sounds fine. It's just when it comes through OBS, it doesn't. All right, so the magnitude of a vector is it's sometimes like shown as like the two vertical bars. There we go. And you do it as the square root of the first one squared plus the second one squared. So -7 squared is positive 49. 8 squared is 64. That's 64. (49 plus 64, mental math, don't fail me now. Is that 113? Yeah, it's 113. So that's our magnitude. I don't think that simplifies, as 113 seems prime. I don't think it has a perfect square that goes into it, so I'd say that that's our magnitude. The direction, you have to be a little bit careful with this. Let's first draw where the vector actually is physically. So I'm not gonna bother too much doing like a scale. So I really care about like what quadrant it's in. So -7 and +8 means it's somewhere kind of like that-ish in quadrant 2. And this is important because the first step to getting the direction is to do arctan of y over x. So 8 over -7, which, oops, why did I put a negative in front? That's another calculator problem, because that's not unit circle, but arctan is going to give you an angle somewhere down here in quadrant 4, because it's a negative value, and arctan is only in quadrant 1 and quadrant 4. So we're going to have to translate this quadrant 4 into a quadrant 2, and I think we're going to add pi to it in order to accomplish that. I need to actually kind of see what's happening here, though. 113 is prime? Okay. That's how I was taught, Anders, with the angled brackets for vectors and parentheses for points. But I also had like I plus j notation, the vectors physically in like the braces, like it's a matrix. I just figured like the angle brackets is one of the first notations that I was introduced to, so if the person asking this question, then they might have the same thing. Congrats for inner product. Oh, really? Dot product. Okay, thank you. I recognize that more. So yeah, I hope I'm not saying the wrong thing here, but I think if we want to go, or do we do 2 pi minus this? No. I want to make sure I'm being careful here, because I sometimes get mixed up with reference angle. And how you translate it to the angle that you actually want. Because you might think of adding pi to it. That's my first instinct, but might actually want to like pi minus that or something. to get the result in the first quadrant. Oh, that's a way to do it too. I feel like you just do pi minus the angle, which is going to end up being the same as pi plus the angle because it's negative. Or it's going to be the same as adding pi to it. I wonder if Wolfram Alpha will actually verify my answer. So I would say the answer is pi minus arctan of this for the direction. But I am curious if Wolfram is going to back me up on this. Should be plus pi, okay. Angle? No. I don't know how I would get Wolfram Alpha to do what I want to do, but yeah, I would say that the answer is for the direction part of this. You're gonna end up doing pi minus arctan minus 8 over 7, which is, if you use trig identities, is pi plus arctan. Positive 8 over 7. Because arctan is odd. It's not really trig identity, I guess, but yeah. So Jeffrey, I haven't seen you type anything else in chat, so if you're not here, it's all good. But at least how I do that question. No, wait. Oh god, see, this is what I was nervous about. Forgetting, like, right? Why are reference angles so annoying? Signal you wrote is in the third. Really? Oh wait. Is arctan? You're right. Why can't you? I thought you could pull a sign out of an arctan. Can you not do that? It's odd. It's bad that I know I'm not more confident in doing these. Dummies.com, that's what I need. Add or subtract. Okay, so it is with adding subtracting 180. I was being concerned that's like there's some other angle they might have to add. That's it's a helpful thing. I guess you just add 180. Ugh. I guess you do that. And that's because the arctan that we got is it's minus 8 over 7, it would be positive 8, negative 7. We got that, but what we actually want is this. So that's the difference of pi. Okay. Or that's like adding pi. Okay. I'm on board with this now that I actually draw it. Oh gosh, okay. Can you graph 3 minus 6 sine theta on a polar graph? You got the table down on the theta and radius. Oh yeah, so that's one of the ones where you might need some intermediate, or like, that's the ones where you probably need to plug in some more than just the default values that I gave you. So we can definitely do that. When it's a bit easier, if they were both 3s, it'd be easier, but since there's a 3 and a 6, it becomes a different looking graph. Which actually, let me look at the shape first. Oh no, you're good, Anders. Thank you for checking my work. It's like a ribbon. Yes, okay, so this is the shape that I was thinking we would get. Let me show you how to, It has a name. I forget what it is, though. They're not considered cardioids, but, the cardioid with the loop in the middle. I forget what they're called. It might actually be limicon. Either way, the name isn't that important for our purposes here. So you have r equals a face with a mouth? Yeah, kinda. 3 minus 6 sine theta. All right, so let's try our same chart. 0, pi over 2, pi, 3 pi over 2. All right. Sine of 0 is 0, so 3 minus 6 is a negative 3. Oh, wait, sorry. I'm already off to a bad start. Sine of 0 is 0, so you just get 3. Sine of pi over 2 is 1, so you get 3 minus 6 now is negative 3. Sine of pi is 0, so you get 3. Sine of 3 pi over 2 is negative 1, so you get 9. So let's see how far we can get just with these points and potentially plug in some extra ones if we can't figure out the shape. So when r is... Sorry, I reversed my r and theta tables. I was getting confused, like when r is 0. Sorry about that. Okay, when theta is 0, r is 3. So we're somewhere out there. When theta is pi over 2, we get negative 3, so we come down. When theta is pi, we get positive 3. Really? Okay. Oh, okay. Wait. Leprechaun. 3 minus 6 sine theta. Oh, yeah, this works out. Okay. So, okay, and then when theta is 3 pi over 2, down here we get 9. So, yeah, as you said, this is one of the ones where, like, you know, you don't want to just connect the dots like that. It's, you know, it's wrong. I wonder how you know that, like how you know that you need to plug in extra points though, because like it might be one of those things where you just need to know the forms of polar curves. What will be a helpful other point to plug in here? Because yeah, you're right. Like we do get this. Like correlated with the loop thing. I don't think I drew that right though. Where's that other intersection point? Because there's like three, I guess there's 4 points along. Oh. Okay, this one has like a special like. I see the helpful point that to plug in, because sine is sometimes 1/2, and 6 times 1/2 is 3, and that'll get us r equals 0. So sine is a half at pi over 3. Sorry, pi over 6. Yes, pi over 6. So you get 6 times 1/2 is 3, 3 minus 3 is 0, and that's where you get some extra points from. So I think those are the important points. I feel like my shape is like slightly off here. I think I did the loop too low. So we still have pi over 2, -3 there. But we also have pi over 6, we'll be up there, but if r is 0, we have a point there at the origin. The other place where sine is positive 1/2 is at pi over 6. Pi minus pi over 6, basically. 5 pi over 6. And so we get another point there. So that's how you know it crosses over that point twice. Man, that's a tricky one though. If I didn't graph it first, I may have messed up. Well, I already did mess up, even though I did graph it before, but I would have messed up worse. So it was that like that double like crossing over point that I was getting confused on at first. I'm kind of curious what the graph looks like if that's like a 5 or something that doesn't. I think you still get a crossing over. It's just not as convenient of a spot. Yeah, we're definitely right now. I just was missing something before. If this is a 5, just out of curiosity, I think it's still the same shape. It's just not as clean to solve for. Yeah. Mixing the pi. Yeah. Right there, I was doing the unit circle trick to translate pi over 6 over to quadrant 2. So yeah, I guess that example is nice where it gives you like nice clean unit circle values, but I think in general, if this number isn't equal to this number, I think you often get some kind of loop. If we reverse these, do you still get a loop? No, you get something weird. But I guess if the first number is less than the second number, you get that like inner loop there. Dang it, I muted my mic to drink water and I never unmuted. Thank you for that, Zoomedo. So yeah, Tyson, I'm glad I was able to help you. The 5 petals part, yeah, that's where polar curves get really crazy. I'd have to look up like how you get those again, if you're curious. And that's true, but you get horrible looking things with a lot of polar curves. I'm gonna try playing the music again. I hope it doesn't cut out. I just tried a different fix for it this time. Sounds good? Okay, thank you. So I'm not sure how much progress I'll making this book on stream, because obviously there's like, you know, conversations to have and people asking questions, but since there's a bit more downtime, I guess we'll go back to looking at this. I don't know, is that important to understand the proof of this? Maybe I'll just try and skim it. And just look at what the actual theorems are and ignore the proofs for now. Um, 3 cosine 6 theta. Oh wow, yeah, that's I can try and Google it and figure out if you're actually asking like to figure out how many petals there are. I assume it has to do with the 6, like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So maybe it's double whatever's in front of theta? I'm not sure though. And sine or cosine will just change the alignment. So yeah, I don't. If you want to like look more into these, then let me know. But yeah, I know it's like those are a bit of a crazier one for sure. And yeah, underscore. This is for Penn Center's reading group. I've been kind of wishy-washy on whether I'm gonna really try to keep up with it, but I figured I should at least try because it would be good to know algebra, and this is like the preliminary part of the book. It starts with number theory, and then it goes into some other things too. Okay, that's right. Critical thinking, yeah. If you have a question, please feel free to ask. Go for it, yeah. This was in Euclid's Elements, really? I didn't realize that Euclid's Elements went into number theory too. I assumed it was just geometry. Arc length, you know when to isolate y or x. Um, Critical thinking, I'm sorry, because I can't remember what like kind of math class that you're in. Something like the calculus arc length formula? Calculus 2, okay, thank you. And there's, I guess so. After we deal with critical thinking's questions. For real x, y values 0 less than x is 0 less than y is 1. X plus y minus, really? Okay. So critical thinking. In theory, you can always do it with either, as far as I know. But usually one way is a lot easier than the other. And a lot of it just has to do with personal preference. Well, I mean, sometimes they're actually about the same, to be honest. So there's an element of personal preference, and sometimes you kind of have to try one, and if that doesn't work, you try the other, to be honest. If you have like, if you want to give me an example of a function that you had trouble with, you like I could tell you my thought process as I look at it for what I think would be easier. But if they give you bounds, like, you know, like this site gives you like explicitly bounds in x and bounds in y, that's a pretty big hint, I would think. Yeah, please do. Yeah, maybe it's not all. Maybe when I said it's theoretically always possible, it might not always be possible. I with unless there's some crazy like functions that I'm not aware of. And I think I see how we prove that. I think I have it worked out in my head, but I would actually need to write it down. Ooh. Semi-cubical parabola. Is that equal to 1, or it should be equal to something, right? Or do they not tell you that? So, like, it needs to be equal to something. It's not equal to 1. It's kind of a funny graph, though. Semi-cubical parabola. Because, yeah, it's not really... You can't do anything with just y squared minus x cubed. You need to be equal to something. Otherwise, it's not a function. It doesn't have to be why. It needs an equal sign somewhere. Like that. That's how you want it to be. Critical thinking. You always want to get it so it's y equal to something or x equal to something. They might give it to you, or they're mixed in together, something like this. But the thing is, I filled in the equals 1 on my own. Like, we need to know what this is equal to, because this is just me guessing. In the second one, we need to know what the second point is. Yeah, you're right, Anders. This isn't an actual function because it fails the vertical line test, but I'm not worrying about that part right now. So, critical thinking to the book. C equal to 0. Oh, 1, 1. Oh, yeah, it's probably equal to 0. 1, 1, and 4, 8. Okay, it's probably equal to 0. You're right. Okay, so critical thinking, this is an assumption, but we can talk through this first one if it's equal to 0. So you have y squared minus x cubed equals 0 from 1, 1 to 4, 8. Okay, so critical thinking, this equal to 0 is my assumption here. You didn't write that in your comment, but this is probably equal to 0 based off the points. And if you don't have an equal sign somewhere, this problem just isn't possible. So tell me if I'm wrong there. How I'd approach this problem is you can isolate if x or y pretty directly. And so let's just see what both situations look like. So if you isolate x, we have y squared equals x cubed. Take the cube root of each side. So x cubed is the same thing as y to the 2/3, we could say. Oops. No cube there. So y to the 2/3, that's not too bad to integrate. It's just a power rule. If we isolated y, start with the same thing, y squared equals x cubed. Now we square root each side. And we have to be careful here with, positive or negative square roots. Here we want the positive part of the square root because we're going from +1 to +4. So we don't need to worry about any negative signs here. And you can also write the square root of x cubed as x to the 3/2. So I say these are of equal difficulty to integrate, and you can choose either one you want, really. Oh, y squared equals x cubed. Okay, that's the same thing. Sorry, maybe I misread it, but it looked like a minus sign. But you can rearrange this to be the same exact thing. So everything I said is still true. So yeah, I mean, what I wrote was just if you subtracted x cubed to the other side. So this is fine too. Everything I said here is still applicable. So if I were to choose one, I would choose integrating with x because the x's have lower numbers for the bounds. So maybe it'll be a little bit easier to calculate things. So I'd say your arc length s is from 1 to 4 of x to the 3/2 dx. And then you do your power rule, so 2/5 x to the 5/2 from 1 to 4. 4 to the 5/2 is 32. Let's get 64/5 minus 2/5 is 62/5. And if you did it with y, it should be the same exact thing. Hey, Japheth, Lyra Adams, do you solve discrete math? I'm not very good with discrete math. I'm sorry about that. Yeah, I mean, you could try putting the actual problem in chat, but discrete math I'm not super good with. Yeah, sorry about that. So underscore your other example is, I need the second point for y squared equals x. What was the second point for y squared equals x? Okay, Anders, sounds good. Hey, Scorpra, how's it going? Oh my god, I can't talk. Critical thinking. I need the second point. You said from 0 to 0, but I don't know what the second point is. There is no given second point? To 4 star. 4, 8? No, for... Oh! I was talking about for the second question, y squared equals x. I got the answer for the first one, 62 over 5. Yeah, I did. That's the s equals the integral. Oh my god. You're right. I forgot to do the actual formula. Okay, sorry. That's completely my bad. Sorry, I literally forgot what the arc length formula is, apparently. Okay, so... So you're gonna have to derive one of these and then integrate it back with a square root, which that's a little bit harder to tell what's gonna be easier or harder. Actually, no. I wanna take this because the formula that we're gonna use is square root 1 plus dy dx squared, or that flipped. But the important part is the squared. And I want that squared to get a cancellation with the over 2 in the exponent, because I think that's going to make this simpler. I hope it will, at least. If you have the 3 in the denominator, then you don't get any cancellation. So let's work with this. Means dy dx is 3 over 2 x to the 1/2. Okay, good. Yeah, this shouldn't be too bad to integrate. So now when we set up the actual arc length integral, it's s equals 1 to 4, a square root 1 plus 3 over 2 x to the 1/2 squared dx. That's the actual arc length formula. Oh, I didn't bring up the camera. What if you isolate x? Do you get the same answer as y isolation? Yes, you should get the same answer. But this way, I think, is going to be easier because that squared is going to cancel with the 1/2. We can show with this as well, or show why it'll be harder. But let's follow through with the integration here first. So yeah, when you square that, the 3 over 2 gets squared, the x to the 1/2 gets squared, and you get 9 over 4x dx. That's just a u sub. 1 plus 9 over 4x du is 9 over 4 dx. Root u du. Integrating root u, you do 4 over 9 times 1 over the new power, just 2 over 3 times u to the 3 over 2. And then I'm going to unsub and do that fraction math. 8 over 27 times 1 plus 9 over 4x, evaluated from 1 to 4. So from 4, you get 10 inside of the parentheses. So 80 over 27 minus times 1 plus 9 over 4 is 13 over 4. It's annoying math. Really? I'm gonna let Wolfram Alpha do that, but so yes, in the end, it theoretically doesn't matter if you use X or Y, you should get the same answer, but one is usually easier. So I'll show doing it with Y instead. Dx, dy, and Y, it's so much harder. So if you derive y to the 3 over 2, you get 2/3 y to the negative 1/3. And this is not going to be as clean. From 1 to 8. So now when you do that squared business, and good luck integrating the square root of 1 plus 4 over 9y to the negative 2 over 3. I don't know. You have to do some weird trig thing, I assume. That's not an easy integral. We can check them both in Wolfram Alpha, though. Try both, find the easier one. Basically, critical thinking, yeah. You're back, Anders. Welcome back. Do you change the bounds from change of variables? No, underscore. I just drop the bounds entirely and I add them back when I unsub. Because I'm lazy. So I was trying to explain that before, critical thinking. The way that I've figured this out is in one scenario with the derivative, we have a 1/2. In the other scenario, we have a negative 1/3. And I know as part of the formula, it's going to get squared. So you always want to take the thing with the square root rather than the cube root, because the square root is going to give that nice cancellation. You can even tell from this stage, like from these two equations, because that has a denominator of 2, that has a denominator of 3, and deriving it isn't going to change that. So even once I saw this, I knew that we want to take this, because that over 2 denominator is going to cancel with the squared. But you're just trying to think ahead to this formula and what gives you an easy like u sub, or what can cancel with the squared, or just like what gives you a simpler thing, basically. And what helps is that I've also done it the wrong way a million times. So you need to try both, then decide. Yeah, look at the isolated forms and which one looks simpler, basically. That one, it's not necessarily obvious which one is simpler, because they're both like about as simple, but same thing ahead to the formula and think about which one gets squared. And just myself, I want to verify the result of my integral. Roots? Why are roots involved? Because I dropped the 3 over 2 power, doy. I made a little oopsie at the end of my integration. I forgot there's a 3 over 2. But yeah, so that's one answer. Really? Underscore? The Y one looks like so much harder. What? Oh, dx. D. Come on. dy. All right, same exact answer. 7.6337. 7.6337. And I was where you're saying to take u equals 1 plus 4y to the minus 2/3. Oh, Hornful says the same. You still get some weird looking stuff. I wouldn't want to do this integral. The other one's much easier, but I guess you can do this. No, same. The answer from x and y is the exact same. Just x is so much easier. Yeah, if you get different answers, then something went wrong. Go for it. Critical. I'm gonna stream for a ton longer because my voice is starting to hurt. I'm happy to look at it at another one though. I also heart 2 is less than x. Oh shoot, and then there's Anders' problem 2. All right, this is a fun one. There's no way we're isolating x here, so I think we're gonna have to isolate y. Let's try it though. Actually, can we isolate? We might be able to. I don't know. You know, it actually it is possible to isolate x. I lied. I was thinking it looked too crazy to isolate x, but I think it's possible. You basically try different things until something works. X squared minus 4 cubed. I'll explain more. Don't worry, I'm just trying to copy down the problem for now. Y is greater than 0? Does y have a different bound as well? Maybe it doesn't need one. So what I was doing in my head that made me think it's not possible is that if you were to multiply out x squared minus 4 cubed, you get some crazy polynomial with like x to the 8th, x to the 6th, and it just gets super messy. But you could just cube root each side, add 4, and then square root. It looks messy. Y is greater than 0 is just all we get? Okay. Working with y is greater than 0 is kind of rough. I kind of want to... We have to do a lot of work to figure out if we were to integrate in terms of y. If we were to isolate x and integrate in terms of y, figuring out what to actually integrate over seems kind of hard. So I'm inclined... I'll show how to isolate both variables here, but I'm inclined to isolate y and integrate with x where we're already given our bounds. Can we use a u substitution like a biquadratic? Are you already head to the integration or like a u sub at this part? I don't know. So I'll start by showing if you isolate y. So let's divide by 36 and square root each side. We'll take the positive square because y is greater than 0. So we divide the 36 over. 36 is 6 squared, so 1/6 times x squared minus 4 to the 3 over 2. 3, because square root is the same as dividing the exponent by 2. Now you can isolate x if you cube root each side. X squared minus 4. Now you add 4. Equals x squared. Now you square root each side. And you get that monstrosity. That looks terrible. And I still wouldn't know what to integrate y over without doing a lot of work. So I much prefer this. So let's get dy by dx. So power rule first. Multiply by, okay, 3 over 2. Square minus 4. Then chain rule derive the inside times 2x. So that's 1/4. Oops. 3 over 2 becomes 1/2. Can you integrate me in your bed? Oh, I'd never ban you for that, Ben. 3 over 2 times 1/6. It's 1/4 times 2 is 1/2. X. Square minus 4 to the 1/2. All right. That's our dy by dx. Let's plug into the formula for arc length. 2 to 3. Okay. Oh, I always forget the 1/2, dude. So I guess we'll follow through with the integration here. It's definitely better than whatever this would be, I think still. One half squared is 1/4. X squared, and then the 2 and the 1/2 cancel. let's multiply out the inside. Please tell me that's a perfect square. I would love it if that's a perfect square. It might be a perfect square. How do we factor that? It's going to be like a 1/2 x squared, 1/2 x squared. We need minus signs in the middle. Is it going to be 1 and 1? The ones check out, the 1/2 x squared check out. You get minus 1/2 x squared minus 1/2 x squared. Hey, oh my god, that's beautiful. So that factors to 1/2 x squared minus 1 squared dx. Look at that, square root squared. Just get 1/2 x squared minus 1 dx. That we can integrate. Oh. Three cubed is 8. 8 over 6 is 4 over 3. Minus 2 minus, oops, minus 3. Wrong, Jed? Oh, I was doing 2 first for some reason. You're right. 3 cubed is something, but I don't care because I can cancel one of the 3's with a 6. So it's actually 9 over 2. 3 cubed is 27, by the way. Then we plug in the 2. 8 over 6 is 4 over 3. Fraction math, ugh. 27 over 6, 8 over 6. 27 minus 8 is 19 over 6. Ew. Get 13 over 6. Ugly number. But yeah, the setup is probably more important there than the final answer. So yeah, critical, I'd say the biggest hint there is they give you those very easy to work with bounds for x and not very easy to work with bounds for y. And so just for a demonstration, I showed both versions of isolating, but if I was the student here, I would just try it directly with isolating y and doing this all with x if I can. I basically guess and check. It's a fancy, it's like an informed version of doing guess and check. You basically, it's a little bit harder with the 1/4 there. I bet there's a widget for Wolfram, but it involves figuring out numbers that multiply to 1/4 and add to -1. I can try and explain it more if you're curious, but it's pretty hard to like learn at first. And I don't want to like overwhelm you with a bunch of extra information if you're not interested. No worries, critical. 13 over 6. Bam. Okay, so Anders, I don't know if you're still here. I'm sorry that I kept you waiting for so long, but you did give that inequality problem. And there's one step that's a little bit sketchy, but if it works, I think it's only a couple step problem. You are here, okay. Scrolling up in chat. Okay, let me, oops. Okay. So what I'm thinking, we're given 0 is less than x is less than 1, 0 is less than y is less than 1. We want to prove 0 is less than x plus y minus xy less than 1. Okay. So the step that I was wondering if it's a little bit sketchy, but I'm like 90% sure that it works, is I want to multiply those two inequalities, and they're both positive, so I don't think there's any weird things happening with like sign flipping. Because if you know that like 4 is less than 8 and 5 is less than 6, can you also say 20 is less than 48? That's kind of my rationale for why you can multiply inequalities, I guess. If they're less than 1, does that change anything? I feel like it wouldn't. So if you just multiply these two, like, I think you have that fact, and that makes the rest of the problem a lot easier. Because now you can take 0 is less than x is less than 1, add this inequality to it to get 0 is less than x plus y is less than 2, and now you subtract this inequality to get 0 is less than x plus y minus xy is less than 2 minus 1 is 1. So I think that's the problem. It's like that little part that was a little bit like, eh. But I don't see why it doesn't work, I guess. It's not right? Name two decimals if you multiply them together are more than 1. You'd like point... Yeah, no, I like... It's like 0.5 and 0.5. That's less than 1. 0.9, 0.9. That's less than 1. I can't name any pairs of decimals that multiply together are more than 1. You can't subtract them? Really? It's that step that you're saying is wrong. Could I multiply it through by -1? That doesn't really help us, though, I don't think. No. It's the reason you can't subtract them. Three is less than 4. 5 is less than 10. 2 is less than 6. Maybe you could break that, though. Two is less than 1.5. I guess, yeah, you can't subtract those two. Huh. I guess, sure, underscore. Is there really not like an algebraic way to do it, though? Switching between x and y, like xy is less than 1? I mean, if you can't do what I said, I don't know what else you do with xy is less than 1. That's for subtracting. Yeah, never mind. Oh, maybe you can triangle inequality your way around it. Huh. But we're given they're positive. I feel like in this case, it does work. It just doesn't generally work. Because, well, I don't know. Draw a square side length 1, put x on the bottom. Well, None of these inequalities are or equal to. They're all strict. So I think the statement is accurate, Richard. So you want to square side length 1. X on the bottom horizontal side. Trace the vertical line from X to the horizontal line from Y. Oh, okay. Oh. This is Y, that's X, and these two are XY? But this is like X squared, Y squared, like X squared plus Y squared plus 2XY is less than, or is equal to 1. That does factor. So, oh, I guess you square root each side. And then now you can do some inequality magic and say that X and Y are positive numbers. So X plus Y minus positive number is less than 1. I guess that works, yeah. Or you just cut out what I did and do that. You can do it directly with the geometric part, I guess. Top left plus bottom right. I don't see what you do with that, to be honest, underscore. How does that correspond with the top left plus bottom right? Oh, I get it. You divided it up in a different way than I did. That's more conducive for the proof. Okay. Aren't you double counting the middle area though, where they overlap? Oh, no. I guess I haven't defined X and Y very well in my work. I'm getting mixed up with like what end of the square we're measuring them from. Okay, I think I see it. Um, what's up, Brodo? Double click on the bottom left, but minus XY subtracts it. Okay. Found out the question. I don't know what you're talking about, Brodo. The answer is Fortnite. Oh, of course. I should have known. um, okay, my voice isn't feeling too great, so I think I'm gonna cut the stream off there. Welcome in, Baroto, by the way, but I think I need to call things for the day. I would stream for longer, but nah. I'm gonna cut the YouTube stream off here. So if anyone's watching on YouTube, I appreciate you. I'll be back on YouTube on Saturday.